This video is Chapter 9, Lesson 4, Ellipses, our third of 4 conics that we've been studying. So far we've worked with parabolas and with circles, and in this lesson, ellipses, the equation for a horizontal ellipse is x squared over a squared plus y squared over b squared, always equal to 1. And if it's a vertical ellipse, then it's x squared over b squared plus y squared over a squared equals 1. So notice that the top is the same. What's different is that the bottom swaps. So, and the larger number is a. The larger number is always a. And both of these equations assume that the center is at 0, 0. When the center transforms and shifts from 0, right, left, or up, down, then we work with this expanded equation. That is exactly what we used with circles, where the center is at HK and the denominator is no change. All right, let's get started with working a few problems. In part 1, we're looking at the graphs. This is on page 620, and I am going to do number 12 first. I'm going to work a couple of problems from each section. There's 3 parts to this assignment. And so we'll start with number 12. And looking at this equation, we obviously have a horizontal ellipse, which has a base equation of this, and this center is at 0, 0, and you need to confirm that that's the case, that the distance on either side is equidistant, and in fact it is. So our center is at 0, 0, and the length of A, which is from the center to the end on the long side, A is 10. This is just counting units, so units from the center to the outer edge of the ellipse is 10. And then the shorter distance, which tells us B, is 6. These are in, well, I'm looking at the wrong one. I was looking at 11, and I would do 12. That's not very helpful, is it? A is 9, B is 4. So filling out our equation, x squared over a squared is 81, and then y squared over b squared is 16. And again, the center is at 0, 0, so therefore it's our basic equation, and this is always equal to 1. All right, so that's for a horizontal. Let's go back and do number 11, which I was trying wrongly to do. 11 is a vertical ellipse, so that has a different base equation. Sometimes in our textbook and elsewhere, sometimes the x squared and the y squared is swapped in a different order because we're adding. It doesn't matter which. 2 plus 3 is the same as 3 plus 2, right? So, but I noticed as I was working through this myself that when we do coordinates, it's always in order of x, y, and I think it just helps our brain to stay orderly if you just keep the x first and then the y second. So, but if it's vertical, what does change is the denominator. So when it's a vertical ellipse, then the x squared is going to be over b squared, and the y squared is going to be over a squared. So that's what's different here, and that's what changes whenever we go from a horizontal to a vertical ellipse, is that the denominators swap places. It is still equal to 1. Okay, number 11. Looking at our diagram, our graph. Our center is still at 0, 0. The distance on the long side, A is always the longer axis. So this distance is in fact 10. The distance for B from the center to the edge of the short side is 6. We just need to fill out our equation now. And so because of the origin, it's simply x squared, and over b squared, 6 squared is 36. And then a squared is 100. And this is our equation for number 11. If you were to write this as y squared over 100 first, and then the x squared second, that would be still a correct answer. In fact, the book lists it that way. So again, it's associative property. So because it's plus, we can put it in either order. All right, I want to go ahead and do number 13 here, because 13, we have the centers elsewhere besides the origin. So looking at 13, first, read your graph, and we have a horizontal ellipse. I can't emphasize enough how important it is to just go ahead and write your equations out, because it helps you to memorize them. And find the coordinates for looking at the graph, and when you do so, you'll see that the center is at -5, -4. Counting from the center to the long edge, the long axis end, gives us the A value, which is 7, and then the B value is the shorter axis, always, 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 and that distance from the center to the edge is 5, to the end of the minor axis is 5. So fill out our equation. All right, so we're not at the origin anymore, so we need to expand our equation like so. And we fill this in with our h and k. So -5 is h. So this is x minus -5. It's going to become a positive. And then this is our k value. So it's y minus -4. This becomes positive. And this is horizontal. So a squared goes underneath x. And a squared is 7 squared makes 49. B squared would be 25. It always equals 1. And that is our equation for number 13. 14, solve on your own. The answer key is linked on Google Classroom. Let's move on to part 2. In part 2, we are writing an equation of an ellipse given the vertex and the co-vertex. So we have some interchanging vocabulary here. The vertex is plural. So the vertex is the endpoint of the major axis. So they're giving us the endpoints of the major axis and the endpoints of the minor axis, and then we're tasked with finding using that information to write an equation. All right, so we are told in number 17 that the vertices are at, so there's vertices and co-vertices. So the vertices are going to be are going to go along with our major axis, meaning the longer axis. So this is going to give us our A value. And then the co-vertices are the end points of the minor axis, which gives us our B value. So vertices are at -6, 4, and 12, 4. So y is the same. That means that y is equal to 4, and this is a horizontal, meaning this is going to be a horizontal ellipse. And co-vertices is our minor axis, and that's going to be, those are at 3, 12, and 3, -4. So the x values are the same. So x is equal to 3. And so our, again, this goes along with this being a horizontal ellipse. All right, so the y values are the same. Here are our x values. This tells us that our center is at 3, 4. And then what is our A value? So the distance, so absolute value of 6. So we're going to add 6 to 12 and get 18. So the full major axis, the full length of the major axis is 18. And then the distance from the center to the edge is going to be 9. So A is equal to 9. And then the minor axis, so that full distance, we have 12, solving number 17, 18. Yeah, so 12 and 4 is 16. I got discombobulated. It's also very late. All right, so 12 and 4 is 16, divided by 2 is 8. I was confused thinking I had mixed things up, but this is, because these distances are close, this means it's almost a circle. So it's a very full ellipse that's almost a circle because the values are so close together. And that makes sense, doesn't it? Okay, so all that being said, horizontal ellipse, x squared over a squared, center here. So x minus 3 squared plus y minus 4 squared over a squared 9, that's 81, b squared 8, that's 64, this equals 1, and that is the correct answer. All right, I think that's all that I'm going to solve for here. I think that speaks for itself. You can always plot these points if it's helpful. I find it helpful, but just the more that I've looked at it, I get used to looking at the numbers and what to add and how to work with it. But if you don't see, if you're not sure how to work with these points, you can absolutely, and you should plot it unless you're comfortable not plotting it. All right, so this was number 17, and then on your own you need to complete 18, 19, and 20. Check on the answer key. That completes part 2. And part 3 is when given an equation, determine the center and the A value and the B value, and then graph it. So I will do this assignment is to do 24 through 26 and also 29, which is that wonky, crazy equation like we did in class. I will solve 24 here. And 24, we are starting with this equation. All right, we can see that the center is at 3, 2. So we need an A value. Actually, the equation asks us to find the major axis and the minor axis. And we need an A value and a B value in order to graph it. So, which one is A and which one is B? Our bottom value, this is a square. One of these is the square of A, and one of these is the square of B. And we know that A is always our longer value, right? So it's literally just about looking at the bottom numbers and which one is bigger. And 128 is obviously bigger. So based on that, we then know that this is our A value. We need to find the square root of 128. Use your calculator. And this approximates 11.3. So since this is A, that means that B is square root of 36, which is 6. So A is approximately 11.3, B is 6, and now we have what we need to graph. The textbook question also asks us the length of the major and the minor axis. So the major is going to double that. 22 and the minor double the 6 gives us 12. So that's just answering the textbook questions. But what we really need is A, B, and the center. All right, let's graph now. So this one, this is a vertical ellipse. And it's shifted like so. Can I make this smaller? Ooh, look, that's nice. It's kind of still there already. All right, so our center is at 3, 2, 1, 2, 3, 1, 2. So here's our center at 3, 2. And it's vertical, so that means that A goes up. It goes up 11. It's just above that. And then down here, we'll go back to the center, count 11 down. And our B wing is 6 on each side. and then connect. Actually better than my ellipses had been. All right, that is the graph for number 24. Again, the larger value in the denominator tells you A, and because this is under Y, that tells us that we have a vertical ellipse. If the larger number was under X, that would place A under X, and that would be a horizontal ellipse. All right, you are to do 25 and 26 on your own. And I'm going to solve the wacky, wonky, crazy problem number 29 here on the video and be done with the video. All right, number 29. All right, we are going to first associate the like variables. And ultimately, we're seeking to write an equation that looks like this. I wonder if my cursor can be seen. Sometimes it can be seen. I know this will work. We're seeking to write an equation that looks like this. We need the top to look like so. So we have this long polynomial, basically, lots of terms. We're going to associate the like variables. 3x squared minus 18x plus 4y squared plus 24y. We're going to move the constant to the right of the equal sign. That becomes -3. Now I'm going to prepare to complete the square with the x and then the y. And in order to complete the square, I need to pull out the common coefficient factor of 3. And checking, this does multiply back. So what I've done here is I've pulled out the 3 as a common factor from here. And then same with these two. I need to pull out the 4. And that leaves y squared plus 6y. Still -3 hanging out on the right side. Now I'm going to complete the square. I'm going to have fun with colors. I need a spot for completing the square. And in order for my equation to be in balance, I need to do to the right what I've done to the left. And I have to apply the coefficients as I do so. So it's going to be plus 3 times whatever is added here, and plus this coefficient of 4 times whatever is added here. And that's going to cause my equation to be in balance. So completing the square, half of 6 is 3, 3 squared is 9. Plus 9, plus 9. Again, half of 6 is 3, 3 squared is 9. Plus 9. And now I factor. So this is a perfect square trinomial. It factors to x minus 3 squared plus 4 times y plus 3 squared. And then doing the math on the right side gives me the value. So -3 plus 3 times 9 plus 27 plus 36 gives 60. All right, so I do have some square binomials. which looks more like my equation. But what does our answer always equal in our ellipse equations? It always equals 1. So I need to divide everything by 60 in order for my equation to equal 1. So doing the math, 3 goes into 60 20 times. So on top we will have 3 divided by 3 is 1. 60 divided by 3 is 20. We're going to divide 4 and 60 by 4. The 4 goes away. At the bottom I have 15. And now I have 1. So now I have a happy circle equation. Ellipse equation. I'm not done with my problem. I now need to find the center, which is at 3, negative 3, the a value and the b value. Which denominator is larger? This denominator is larger. So this is my a value. And so a equals the square root of 20. And then this is my b value. And b is going to be the square root of 15. Square root of 20 is 4.5 approximately. Square root of 15 is approximately 3.9. And I have my center value, so we can do our, we're graphing here. Okay, so I don't need this to be so. All right, 3 negative 3 is my center. And because the a value is under x, then I have a horizontal ellipse. So that's my long value is horizontal. So a is going to extend right and left from center. 4.5. And then b will extend vertically from the center. Almost to 4. And there is my graphed circle. All right, that's it.